Okay, this is an application problem from the section on properties of the determinant. And what we're going to do is look at Cramer's rule. And of course, you learned this in your Algebra 2 class. It's about a system of equations, so we'll start with just a 2x2 system, although this extends to higher systems too. Suppose we have a system ax plus by equals alpha, and cx plus dy equals beta. Well, of course, to solve this system by substitution, we simply take the first equation and solve it for x. So x would be equal to alpha minus by, and the whole thing divided by a. And then we would substitute that into the second equation. So it would be c times the quantity alpha minus by over a plus dy is equal to beta. And then let's use that to solve for y. So to do that, we want to put this over a as well, so we can put it in a common denominator. So this would be y over a. So it's going to be c alpha minus cb y plus, and then this will end up being a dy, and the whole left side is going to be over a, and that equals beta. So we'll multiply the a across. So we get c alpha, and then I'm going to go ahead and factor out the y here. So it's going to be plus y times the quantity ad minus cb. And then that's all equal to a beta. And we'll bring the c alpha to the other side and divide. So y then will be equal to ad minus cb. And then the whole thing, excuse me, it'll be just the opposite. It'll be a beta minus c alpha, and then it'll all be divided by ad minus cb. That's what y will be equal to, and then let's go back and substitute that y in for x. So x then will be equal to alpha minus b times this quantity, a beta minus c alpha divided by ad minus cb, and then all of this divided by a. Okay. So what I want is for alpha to also be over a common denominator of ad minus cb, and then there'll be an extra a in the denominator of that because the whole thing's divided by a. So it's going to be alpha over a times ad minus cb times ad minus cb. And then that denominator extends all the way across, and that'll be minus b times a beta minus c alpha. So we can clean up the numerator a little bit. It's going to be a alpha d minus c alpha b minus ba beta plus cb alpha. And if we notice, cb alpha is in there twice, here and here, so we cancel it out. The other two have a common a, so it's going to be a times alpha d minus beta b, and then all of that is over a times ad minus cb. So the a's cancel, and that means x is equal to alpha d minus b beta over the same denominator, ad minus cb. So this is how we would solve the system if we were just solving it directly by substitution. So note the answers for x and y. This is a pretty common process, substitution, and you've done it before. Well, now let's look at what we would do with Cramer's rule. Cramer's rule says let's establish three matrices. Matrix A is going to be the coefficient matrix. A, B, C, D. And then we're going to establish two additional matrices These will be augmented matrices where we take the solution vector, alpha over beta, and we replace either the first column or the second column of the matrix by it. The matrix AX will feature alpha and beta, replacing the X coefficients, so A and C. So it leaves B and D. And a second augmented matrix is going to be AY, and we'll do just the opposite. So it'll be AC, and then the Y column of the coefficient matrix is going to be replaced by the solution vector, which is alpha beta. And then what Cramer's rule asks us to do is evaluate the determinant of these. So that's what we want. I'm going to go ahead and say the determinant of these is then going to be equal to, well, in this case, it's AD minus CB. In this case, it's alpha D minus beta B. And in this case, it's going to be alpha A beta minus C alpha. And then Cramer's rule says further that we can then find the solutions for X and Y by just taking the ratio of these determinants. The X variable from the original system is just supposed to be AX over A. And of course, if we look at that, AX over A is going to be alpha D minus beta B divided by AD minus CB. And I think that looks familiar to you. That's exactly what we got by solving the system sort of the standard way by just using substitution. Of course, Y is going to be the determinant for the AY matrix divided by the determinant for the coefficient matrix. So that's AY over A. Oh, and then again, these are determinants. And that, of course, is going to be A beta minus C alpha divided by AB minus CD. Oops, CD. And, or AC minus BD, sorry, AD minus CB. And you can see that's the same solution we got over here. So in the case of this 2x2 system, you can see that Cramer's rule produces the same answers we get through substitution. And that's always going to be the case. The ratio of these matrices simply replicates the substitution process. So it becomes a simple way to solve a system by using the ratio of determinants. Of course, we've already found out that it's much easier just to take the augmented matrix here and go ahead and put it in reduced row echelon form. So we have a number of ways to solve systems that's much easier than this, but this at least contextualizes Cramer's rule for you and shows you the role that the determinant plays in Cramer's rule.